So I'm here to talk about application packaging. And before I really get started, I want to talk about kind of the genesis behind this idea that I had, because this is going to be very much a fundamentals talk. I noticed I was giving a lot of talks where I'm like, I assume you already know this. But when I was going to conferences, no one was really talking about the this that you were already supposed to know before you walked into my talk and were able to understand it. So this is a talk about this. Before we get started, there's two things I'd like to mention. The first is that all the slides, speakers, notes, and the demos are available for download, and I'll be providing a link at the end of the talk. I tend to be one of those folks who can't keep up with the speaker and take notes at the same time. So for those folks in the same situation, no need to take notes. Everything I'm going to be talking about is going to be available for download. So what are we talking about in this session? We are discussing how software gets onto a Mac using Apple's defined methods. So Apple defines the following deployment options for software installation. The first is deployment via a zip archive. In this scenario, the person receiving the zip file opens it with Finder to uncompress the contents, and any file permissions associated with the zip file are not preserved, so the user account that is uncompressing that zip file has file ownership of whatever comes out of that zip file. Second is deployment via disk image. In this scenario, the person receiving the disk image opens it with Finder, which causes the disk image to mount. The recipient can then either choose to run the application either from the disk image or copy the app to an alternate location. So if they choose to copy it elsewhere, the file permissions associated with the app aren't preserved. So the user account doing the copying has file ownership of the copied application and any other files that they copied from that disk image. So the third, and the one we'll be discussing today, is deployment via an installer package. So in this scenario, the person receiving the installer package opens it, and the installer application launches. The recipient then runs the install process of the application using the installer application. Now, depending on how the options for the installer package were set when it was created, it may request an admin user's credentials in order to allow the package to be installed using root privileges. So this ability is going to allow an installer package to install an application with the defined set of file permissions, in contrast to the other two installation methods I just mentioned. So in this case, an installer package will allow you to preserve those permissions where the other two won't. So for this ability to define and preserve file permissions alone, using an installer package is the best way to deploy software where Macs are being centrally managed. However, there are other reasons to prefer an installer package for deployment. So with packages, you can use scripts to run pre-installation and post-installation actions, preserve application metadata if you so choose, sign installer packages, notarize installer packages, and you can also install packages using MDM commands. So there's an asterisk next to that last item, which I'll get to more in a bit, as you'll need to have an installer package with the specific configuration in order to install it using MDM commands. So as macOS has evolved over the years, there have likewise developed several categories of package files. There's going to be component, distribution, and legacy. Legacy are bundle-styled installer packages. So what's the difference between them? So there's two main kinds of packages. There's flat and there's bundle style. Both component and distribution packages are flat. Well, what's that mean? It means that both component and distribution packages are actually XR archive files. So XR is an open source file archive format developed by Apple, and it's used when you're creating packages. Now, bundle style packages are Apple's legacy package format, which uses a bundle style format similar to Mac applications. So a quick way to tell the difference between the two is to right-click on a package. If you get the Show Package Contents option, this is a bundle-style package. And if it's not there, it's a flat package. So the reason for the difference is that a bundle-style package is actually a directory containing a number of files. In contrast, a flat package is one compressed file. So I'm really not going to be spending a lot of time discussing legacy bundle-style packages during this talk because Apple has started the process of phasing them out. On macOS Sonoma, installer will display a warning if you try to install a bundle-style package. And on Sequoia, they just don't work. So for the most part, vendors have moved on to using flat packages and are no longer using legacy packages. Some vendors have taken a little while longer in this process than others. But at this point, we're really just talking about flat packages, which are component and distribution. So what's the difference between those? Well, component packages are going to contain up to two parts, payloads and scripts. Now, it's possible that a package may have only a payload, and it's possible that it may contain only scripts, but it can contain both. So component packages don't really have anything extra. They don't include like the ability to include a license file or the ability to install additional packages. Now, distribution packages can contain one or more component packages, and they may also include additional resources to customize and control the user interface shown in the installer application. So a good example of this is the Microsoft Office Full Installer, which has a customized welcome screen. It also has a license screen. And it will also give you options for installing all or some of the included installers. And the included installers are embedded component package installers. So one commonality with all types of installer packages is that they can contain payloads and scripts. So what are we talking about when we say payload? Well, it's everything that the installer package is going to install in terms of files and folders. It may be an application, it may be directories, it may be scripts, it may be some combination of all of those, but ultimately a payload is what your installer package is putting down on that Mac. So if you have the installer package, you can access what's inside the payload by expanding the package and looking inside. And you can use the package utils tools expand option for this. So let's take a look at how this works. So in this case, I'm going to use package util, and I'm going to say expand. And I'm going to provide it the path to a particular installer package, which is show or hide desktop icons .pkg. And I'm going to tell it that I want to put it into a new directory called package inspection. And now let's go ahead and open up that directory. And I've got a directory called package inspection, and inside there I can see the various components that came out. Now, if you notice with the package I just expanded, I didn't see the actual files in the payload. I just saw a file called payload. Well, to additionally uncompress the payload file, the package util tool has an undocumented option called expand full. So let's take a look at how that works. So again, we're going to run package util. I'm going to use expand full, and I'm going to provide the path to that same install package that I did before and have it create that package inspection directory. All right, everything looks good. Let's go ahead and open up that directory. And now you can see that payload is a directory, and inside that is the application I'm installing, which is an app called show or hide desktop icons. So one interesting twist can happen with distribution packages, which we'll be discussing more in a bit. When you expand those, you'll often see what looks like another installer package inside. However, this isn't an installer package. Instead, it's a directory with the .pkg file extension tacked on at the end of the name. How do you fix this? Well, you remove the .pkg from the end of the directory's name using either the finder or the mv command from the command line. So once the OS no longer thinks it's an installer package, you can look inside and access that payload. What if you want to access scripts inside an installer package? Well, in this case, assuming you don't want to also access the payload, you can just use the expand option in place of expand full. So let's see how that looks. So I'm going to go ahead and run package util, use the expand option, and I'm going to provide the path to a Java installer and put that into that package inspection directory. All right, and inside that installer, you're going to see something, a directory called scripts, and inside that is going to be a pre-install script. So this is how you would be able to access that script inside the installer package to take a look at it. So say you don't have the installer package available. How do you know it's in the payload? Well, you can check the receipt. Anytime an installer package is installed, with one exception I'll be discussing later, a receipt for that software installation is generated and stored on the Mac. And as part of the receipt, there's a bill of materials, or BOM, otherwise pronounced like BOM. So you can read the BOM via the .BOM files, which are left in var db receipts following the installation of the installer package. Now, by itself, the BOM file isn't readily readable, but you can see what's in the BOM using the lsbom command line tool. So let's convert the BOM for a bb-edit installation. And what comes out the other side is going to be a listing of the files and directories that were installed, their permissions, the UID and GID of the account and group which own the files, the file size, and a checksum. So as mentioned on the BOM man page, the listing may also include more information, like information about hard links and the last modification date of installed files. So let's take a look at a simple BOM to see how you can read it. So this line looks like a good example. So here's how it looks broken down. Here we have the file name and the path it gets installed at. Next, we have the permissions displayed in octal format. Then we have which user and group own the file in question. We also have the file size, which in this case is very small. And to make sure what's being installed matches what's expected, we have the checksum. Now, are there other tools that show payload and BOM information? Absolutely. One of my favorites in this area is a freeware tool called Suspicious Package. If you are not familiar with this tool, I really recommend getting familiar with it. It is excellent. So this will allow you to view the payload of an installer package and see all the information in a much more readable format that requires much less work on your part. So here, Suspicious Package is reading a Google Chrome installer package. Now, Suspicious Package can also read the BOM files using .bom files from var.db receipts, though it won't be able to provide as much information as it can when reading directly from the installer package's payload. So Apple's installer application can also show you what files are being installed by an installer package using the show files command underneath the file menu. Now this will open a new window showing the files which are installed by an installer package. It's not as comprehensive as you would get from other tools that can read the BOM file, but it does provide you at least this basic information on what's being installed. So after expanding an installer package using package-util, you can use the package-util's flatten option to have package-util reassemble it into a package again. So one reason why this may be useful is that if you need to edit something in the package, but you don't want to have to rebuild it from scratch. This way you can essentially pull it apart, make your changes, put it back together. Now, one thing to know about this is expanding an installer package will not bring over any code signing or notarization. And this is a topic we'll be covering more later. If you use package-util's flatten option to reassemble the installer package, the resulting installer is going to be neither signed or notarized. So let's take a look at how this works. So I'm going to go ahead and run package-util expand and provide a path to my installer. And I'm going to have it expanded out into the package inspection directory. And by the way, that name is completely arbitrary. I just chose package inspection. All right, so there is my expanded out package. And now let's put it back together. So I'm going to go ahead and run package-util flatten. I'm going to choose my package inspection directory. And I'm going to choose to save that to, I'm going to stick it in my home folder and just call it show or hide desktop icons.pkg, which is the original name of the installer package. Now if we open up our home folder, there we have our installer, and it's complete. So we've essentially built a new installer package, but it has exactly the same components as we had before. So now that we've talked about how to pull apart, examine, and reassemble packages, let's talk about how to build them. So as part of this, I'm going to show you the way to build packages using the command line and also using a GUI tool called Packages. For those not familiar with packages, you can download it using the link at the bottom of the screen. So let's look first at the command line tools that we'll be using. Apple has provided two of them, one for building component packages called package build, and one for building distribution packages named product build. So we're going to look first at building a component package using package build for an app called show or hide desktop icons.app. That's the example we've been using earlier in the talk. Now the first thing we want to do is set up a directory for this package project. So for this example, we're going to set up a new directory on the desktop called example. The name can be completely arbitrary. It's whatever you want. So inside the example directory, we'll set up another directory called payload. For this project, the payload directory represents the location on the Mac that you're installing onto. So in the case of this project, we are planning to install the Show or Hide Desktop Icons app into the Applications directory. So next, let's go ahead and put our application into the payload directory. And at this point, the folder structure should look like this. Now we open Terminal and change the directory so that we are inside the example directory on our desktop. Now, let's build our package using the following command. What did any of that mean? Well, let's break it down. So first is root. So in this case, it's the payload directory inside the examples directory. So as mentioned before, the payload directory represents the location on your Mac where you're going to be installing your app into. And it has all the files that you're planning on adding to your package. Next is the install location. So in this case, we're instructing the package that our payload is being installed into the applications directory. Next is identifier. Now this is a unique identifier string for your installer package to make sure that your installer can be distinguished from other installers by the Mac being installed onto. So the convention for this is to make it a reverse DNS string for your organization. But the exact identifier doesn't really matter, it just needs to be unique. So in this case, I'm choosing to use com.example show or hide desktop icons. Now we also need to set a version number for the installer. This is so that installer app can tell what's a newer version of the installer package as opposed to older versions. So in this case, I'm choosing to use the same version number as the show or hide desktop icons app. So in this case, show or hide desktop icons is 1.3, so I'm just going to set the package to match. Now the last part is naming the installer package, which doesn't have a specific package build option. It's just what's specified at the end of the command, which is up on the screen so you can see it in context. So let's see how the package build command works once this is all put together. So that went by a little fast, but basically I took that command, package build then went, took a look inside the example directory, inside the payload directory, put it all together, and then wrote a package. In this case, it wrote it to the, to my home folder for show or hide desktop icons.pkg. So once that command is run, we now have a new installer package inside the example directory on our desktop called show or hide desktop icons.pkg, and let's take a look at it with suspicious package. And everything looks okay. It did find one warning for a review, and the reason for that warning is that this package is not signed. Anytime you have an unsigned package, suspicious package is going to flag that as something to review. But as you can see, this installer package is set to install into applications. It looks like it is named correctly. It's showing that it's an Intel app, which is correct. And by and large, everything looks fine. So one thing to note is that suspicious package is showing a set of permissions for the application. We didn't set any permissions for the application, though, did we? Well, we didn't. Package build does. So this is discussed in the package build man page for the ownership option. It says that by default, package build will apply what's referred to as the recommended UID and GID, and says it's generally the UID of the root user account and the GID of the wheel group. Now, usually the defaults are fine. But in the event that they aren't, you can override this behavior using package build's ownership option. However, then you'll need to manually set the permissions for the files and folders you add to that payload directory. One other thing to be aware of is that by default, package build will remove all extended attributes from the files in the installer package payload. Now, normally I would consider that to be a good thing because it means it's stripping out things like the quarantine bits and other things that Gatekeeper might not like. But in the event that you do need to preserve these for whatever reason, there is an undocumented preserve xadder option. Now, as with the permissions with the ownership option, you will need to ensure that the extended attributes of all files and folders in the payload are set properly before building your installer package. So now that we have a built package, this is a good time to look at that last file which is included in a component package, which is the package info file. So this is the file that stores the settings that installer uses to install the application, including where to install that payload, what the package identifier is, the version information, and information about that payload being installed. So I'm not going to go in depth about the package info file since we have a lot of material to cover, but for those wanting to dig into it, there is a link at the bottom of the screen that'll provide more information. So now that we've taken a look at how to build a component package using package build from the command line, let's take a look at how you can do this with the packages GUI packaging tool. So first, we are going to open packages and choose to set up a raw package project. So in this context, raw package means a component package. So we set the name we want to use for the project and the resulting installer package. So in this case, we're using the same name that we did with package build, which is going to be show or hide desktop icons. Packages will then create and open up the project file with the number of defaults set. So all the defaults are fine for this installer package, so we won't change anything here. Next, we click on the Settings tab, where we can set the desired behavior for the package, as well as the identifier and the version information. So this is where Packages is asking for the information that will store in the package info file of the resulting installer package. Now, the defaults that are set for these options and for post-installation behavior are fine, as we don't want to trigger a reboot or other behavior on a successful install, and we do want to require admin rights for installation. So one thing we are going to be changing, though, is the version and identifier information to match what we used with package build. So Packages pulls the identifier information from its template settings for projects, which can be changed using the template settings in the Packages app's preferences. So if you know you're going to be using a particular identifier for most of your package, for example, you're going to be naming it com, my company name here, something, this is where you can set that. So I've now updated the identifier and the version information to match what we use with package build. Next, we click on the Payload tab. We add the app we want to install, and then we use Packages default options to have it be available in the Applications directory. Now, Packages also make some default choices when it comes to permissions, which is choosing the root user account and the admin group for ownership. Now, since we want to match what we use with package build, I'm changing the group from the admin group to the wheel group. Now, why does Packages have a different default than what package build does? The reason is that Packages predates some changes that Apple made. When Apple was first getting started, their default was actually to set things to the admin group. Later, they changed to the wheel group. Packages didn't make that change, and so their default is still to use the admin group. It's fine, just change it as you need it. So we're not using the other tabs as part of this project, but here's what they look like. Scripts would be where we would add any pre-installed and post-installation scripts. And the Comments tab is where we would just add any comments about the project. It's basically a page where we can make notes about it. This wouldn't be included in the installer package. It's just there for your use with any note-taking you may want to make in the course of making this project. So let's take a look at how all this works. Let's go ahead and launch Packages. I'm going to select a raw package. Hit Next. I'm going to call this Show or Hide Desktop Icons. All right, let's go ahead and create this. Goes ahead and creates my stuff. Let me go ahead and change the version information to match what I want it to be. All right, that looks good. Go ahead, click on Payload, click on Applications. I'm going to go ahead and tell it I want to add some files. I'm going to go find that Show or Hide Desktop Icons application that I already have in the Applications directory. All right, looks good. Let's go ahead and change that to the wheel group to match what we were doing with package build. Save those changes. And there we go. Next, we just want to go ahead and build. Goes ahead, builds our package. So far, so good. And let's take a look at the resulting package with suspicious package. So again, we're getting that flag for the review because the package isn't signed. But otherwise, this looks a lot like what we were just seeing before with the package built installer. It's installing into applications. The permissions are right. Version's right. Everything looks fine. All right. So now that we've taken a look at how to build component packages, let's take a look at building a distribution package using product build. So as a reminder from earlier, component packages are going to contain up to 2 parts, and that is payloads and scripts. It is possible that the payload may only have a package may only have a payload. It's also possible that it only has scripts. It can contain both. Distribution packages can contain 1 or more component packages, but it may also include additional resources to customize and control the user interface shown in the installer application. So let's take a look at how to build a distribution package using product build. What's the easiest way to build one? Well, you can build it from an existing component package using the command shown on the screen. Don't really need to do anything else. So let's take a look at how this works. So I'm going to go ahead and run product build. I'm going to say that my package is show our hide desktop icons.pkg sitting out on my desktop. And I'm going to go ahead and just name the new one, show our hide desktop icons distribution.pkg, and that's it. Product build took that existing component package, wrapped it up inside a distribution package, and there it is, all set to go. So if we examine both packages using suspicious package, we'll see that the original source package is a component package, and the new package is a distribution package. Now, this is a simple enough process. I'm not going to show how to do it in packages because, honestly, this would take longer in packages to reproduce. This takes like a few seconds. So now, let's get into the part where we add additional resources and multiple component packages to a distribution package. What's that process look like? Well, for this example, we're going to add 2 component packages and 3 text files, a README, a license, and a welcome file for folks to see when they open this installer. So the welcome text will look like this. The README will look like this, and the license will look like this. So this is going to take some fiddling when we do a product build, so let's take a look at that first step, which is building the distribution file. So what we're going to do is use product build to build us a distribution file. And we do that using the synthesize command. We're providing an identifier for our new installer package, which in this case is going to be corp.acme applications. I'm going to give it a version, which in this case is going to be 1.0. And I'm going to tell it what packages I'm planning to include in it, which are going to be package1.pkg and package2.pkg. And I'm going to tell it that I want to name that distribution file distribution.xml. Now, why is creating this important is because product build uses that distribution.xml file to help it assemble its installer package. Because we're asking it to do something more complicated than look at this installer package and just build a distribution package off of it, we're building it a roadmap for it to use when building a distribution package. All right. So this should give us a distribution XML file that looks like this. So we need to edit it to refer to the additional resources that we want to include with the distribution package that we're planning to build. So distribution.xml in this case, for product build, this is going to be the roadmap for building an installer package the way we wanted to do it. So we're going to add the following information to give our distribution package a title, which appears in the installer application, as well as the welcome file, the README file, and the license file. So once that distribution XML file has been edited and the changes saved, let's take a look at how to use product build to create that installer. So in this case, we're going to change to the desktop, and we're going to say product build. We're going to tell it where our resources are, which is in the resources directory on our desktop. We're going to tell it where our distribution file is, which is the distribution XML file. And we are going to tell it that we are going to build an installer called Acme Corporation Applications.pkg. So what it did was that the distribution file told it that it was looking for 2 packages, one called package 1, another one called package 2. It was telling it where its resources were, and inside that it was finding the various files that we'd specified. And it was able to take that information from the distribution XML file and then build that resulting installer package. So let's take a look at that installer package and how it works. So we've got our README, we've got our welcome, got our license. Just hit continue, hit agree. And install, and everything is fine. So next, let's take a look at how you can do this with the packages tool. So first we open up packages, and we choose to set up a distribution project. We set the name that we want to use for the project and the resulting installer package. So for this example, we're going to be using the same name that we did with product build, which is Acme Corporation Applications. So packages will then create and open up the project file, which with a number of defaults set. All the defaults are fine for this installer package, so we won't change anything here. However, we do need to import our 2 component packages into the project. So once imported, the 2 component packages should appear on the sidebar. It's not actually necessary to build component packages separately for a distribution package project in packages, because you can build the component package or packages as part of the same packages project, and then everything will get assembled into that final distribution package. Now, the main reason I'm importing here is to match that product build workflow as closely as possible. So next, let's click on the Presentation tab and select our additional resources. So first, let's go ahead and add that welcome text. Let's add the README text. And finally, let's add the license. And now, let's see how all this works. So I'm going to go ahead and open Packages. I'm going to select Distribution Package. I'm going to name my project as Acme Corporation Applications. All right, looks good. Like I said, packages will actually set you up kind of a template for a component package. But in this case, I'm going to go ahead and import my packages. So I'm going to select Package 1 and Package 2, hit Import, save my changes. So now that they're in there, let's go back to Project, go to Presentation, and I'm going to go ahead and select Introduction, which is my welcome text. So let's go ahead and click the plus button there and choose my location. So I'm going to go into that resources directory and select welcome.txt. All right, that looks good. Next, let's go ahead and select README. Same thing, just go ahead and choose what we got. So readme.txt. Last but not least, let's set that license. And as you can see, there's more options that you can set. It's just that I chose to use those 3, because those are the ones that I needed. All right, everything looks good. Anything I'm leaving out? Nope. Okay, let's go ahead and build. Goes ahead and builds our application. So let's take a look at what it looks like to install that new installer. Got our welcome, got our README, got our license. Hit continue. Hit install. And as you can see, this experience is very much like what I got out of product build. So now that we've discussed how to build packages, let's talk about how to make the real magic happen. And this is when you start using scripts as part of the installation process. So what languages can you use? Well, if a client Mac supports a language, the installer should be able to support running scripts written in that language on that client. So from there, your scripting options are going to depend on whether or not you're using a legacy package or a flat package. So there are 6 types of scripts that can be used in a legacy package. Now keep in mind, on Sequoia, legacy packages are dead. You can't do this anymore. However, most of the time, you'll be running these 2 types. Pre-flight scripts get run before files are installed, and post-flight scripts run after files are installed. The other types of scripts will apply only in specific defined circumstances, which may or may not apply to your installer package. Now, when Apple created the flat package format, they simplified the script options, and they made only 2 of them available. The bundle-style post and pre-install and pre- and post-update script options were removed. Apple retained the concept of the pre- and post-flight scripts, but they renamed those script categories to pre-install and post-install to make their functions more clear. Now, a commonality between scripts used in legacy packages and flat packages are that the scripts must return an exit status of 0, or else installer is going to report failure. So what will happen then is if a script runs into a problem and doesn't return an exit status of 0, you'll get this: the installation failed. Doesn't matter if everything else went right. It didn't get exit status of 0, all fails. So if you're building a shell script for an installer package, one way to ensure that the script returns a status of 0 is by adding exit 0 to the end of your script. This way, it always returns 0. So when building a script for use with an installer package, it's helpful to know that the installer application can automatically pass along information to the script using variables. So the ones shown on the screen are for shell scripts. So here's an example of using the $3 variable in an installer script. So in this case, we're able to take advantage of the installer telling us which drive the package is being installed onto to have our scripts run its actions on that specified drive. So one thing that's important to know is that the closest set of variables to the script is what's going to win. So if your systems management tool assigns $3 to something different than what installer does, the installer assigned meaning is what's going to be used by that script inside that package. So there's lots of cool ways to use installer scripts. You can use them to fix problems. Excuse me. To fix problems in other people's installer scripts, you can install software that doesn't use any of Apple's recommended installation methods. I'm sure we've all got a few of those. Deploy configuration files for other installers, and you can even build an installer package, which is only a delivery mechanism for scripts. So how do we include scripts as part of building an installer package? Well, let's look back to an earlier example where we were using package build to build a component package. So in addition to our payload directory, let's add a scripts directory and put a post-install script inside of it. So your new directory structure should look like this. Now let's build our package using the following command. Now that we're referencing that we have a scripts directory and its location, package build will include the post-install script stored inside the scripts directory as part of building the package. Let's take a look at how this works. So in this case, I've got my command. And the main thing I've changed from before is just I now have -- scripts, and I have specified a scripts directory. Other than that, everything's exactly the same, and package build will build your installer exactly the same way. So now let's take a look at how you can do this using the packages tool. So in this case, I've got everything looks OK. There's my settings. There's my payload. Scripts, I don't have any scripts set up for that. So let's go ahead and choose a script called post install. Save my changes, go ahead and build. Exactly the same as before. The only thing I'm changing is just that I'm adding a script now. So let's see how this looks in suspicious package. So in suspicious package, if I tell it to look at all scripts, it'll show me the script inside that package, and it'll also display what the contents of that incredibly important, very valuable, does a ton of things script. Now I want to talk about one of my favorite things about installer packages, where you can use an installer package as a delivery mechanism just for scripts. So no files get installed in this case because the only thing in the installer package is a script. So payload-free packages is Apple's term to describe installer packages that install no files and which have been built to only run scripts. So Apple has built support for this into its command line package build tool, which is used to build component installer packages. So the no payload option tells package build that the package being built will only contain scripts. So let's take a look at how this works by turning the following script into a payload-free package. So we'll start by saving the script inside a directory named scripts as an executable file named postinstall. Not postinstall.sh, just postinstall. The name must be right, or else installer is not going to recognize it. So the reason for the scripts directory is that package build scripts options are set to look for a directory with scripts inside rather than specifying the scripts themselves. So all it's really looking at is just directory and there's stuff in it. So once the scripts directory is set up and the post install script saved inside of it, running the following command with root privileges will build a payload-free package and store it in the designated location. So once the package is built, you can then hand it off to whoever or whatever needs it, and they'll be able to execute that script without having to know anything more than run an installer package. Now, since we had discussed package build earlier, you may think I've left something out. Version number. I didn't leave it out. When you're building payload-free packages using the no payload option, the version number is not required. Well, how come? Well, when building a payload-free package with Apple's package build tool using the no payload flag, no receipt is left behind. So no receipt, there's no reason for a version number. So I filed a bug on this because this didn't seem right. But Apple said this was intended behavior for payload-free packages built using package build's no payload option. In Apple's opinion, as of the time of this bug report, payload-free packages are a convenient bag for scripts. Any other type of package will leave behind a receipt. This is the only exception that I am aware of. So why is this important? Well, if your systems management tool relies on receipts to tell whether or not a payload-free package has been installed, a payload-free package that doesn't leave behind a receipt means your management tool won't be able to tell whether or not it's been installed, and that could be a problem. This may result in the payload-free package and its associated script being run repeatedly on your managed machine. However, you can make a package with package build that, while technically not payload-free, will act just like one. The key is to create an empty directory and set package build's root option to look there for files. Now, as we talked about earlier, package build's root option is used to tell package build which files to package. But since there's going to be no files in an empty directory, the package will install no files on the destination Mac, but you'll get a receipt. So now that we've covered the ins and outs of building packages, let's discuss how to sign and notarize packages. So these are security measures that you can use to make sure that no one has altered the installer package that you've built. Now, more importantly, using signing and notarization will mean that you can make your installer packages available for download while keeping Gatekeeper happy, instead of blocking your installer package from running. So another reason that signing is valuable is that if you're planning to deploy packages via an MDM command, packages deployed using that method, they must be distribution-style packages, and they must be signed. Now, to get us all on the same page, what is signing? What's Rich been talking about? Well, in the context of installer packages for macOS, signing is a macOS security technology that you use to certify that an installer package was created by you. Once an installer package is signed, the system can detect any change to the installer package, whether the change was introduced accidentally or by malicious code. So likewise, what's notarization? What does that mean? Well, notarization is an additional safeguard against signed installer packages being modified by a malicious third party. So the Apple Notary Service is an automated system that scans an installer package for malicious content, and it checks for code signing issues. So notarization of a signed installer package ensures that Apple has passed the signed code through an automated scanning process, and they verified that the signed code is free of malicious content. So macOS's security tools can check the notarization status of a signed and notarized installer package, and in general, that makes Gatekeeper happy. So since we have limited time in this talk, I'm not going to go into the details of how to get a code signing certificate or how to configure it, but for those who want to know more, I would encourage you to go to the link at the bottom of the screen for information on how to get started with obtaining one. So getting a signing certificate is not free. It will require you to sign up and pay for an Apple developer account. So once you have your signing certificate installed on the Mac that you're using to sign installer packages, how do you reference it when you need to? Well, to do this, you'll need to know what the signing identity is. To do this, you would run the command shown on the screen. And let's take a look at how this works. So in this case, I'm going to go ahead and run that command, which is security find identity. And it's going to give me a couple of signing identities. So which one is the one I want? Well, the one I need to use is the one indicated, which has developer ID installer along with the name registered for the Apple developer account and the team identifier. That's the one I want to use when I'm signing. So when using the command line tools, both package build and product build will have a sign option, which can be used with a signing identity stored in a keychain. So let's take a look at how this works using package build. So in this case, I'm going to go to desktop example, where I had my original project set up. I'm going to say, I'm going to go ahead and run package build, root is payload, that I am installing to applications. My identifier is going to be com example show or hide desktop icons.pkg. So this is going to be just like our examples earlier, except now we're going to be adding the signing options. So in this case, version 1.3, I'm going to choose to sign it. So sign, developer ID installer. So this is going to be taking that information straight out of that signing identity information that we got earlier. And I'm going to be naming that package show or hide desktop icons.pkg. And because it's asking for something, my signing identity and my login keychain, it's asking me for the password for that. And once it has that, it can then take that signing information and sign my package with it. Now let's take a look at how you can sign packages with the Packages GUI packaging tool. So in this case, I'm going to open up my project. I'm going to choose to set the certificate. I'm going to choose, it's the only one listed, but there you go. Now I've got that little badge icon up there that tells me it's going to sign things. I'm getting prompted, same as before, for the signing identity stored in my login keychain. Goes ahead and builds it, and everything's good. So now let's take a look at how this appears in Suspicious Package. In this case, I'm not getting that review flag. Why am I not getting that review flag? Because this time it's signed. Because it's signed, Suspicious Package says everything looks fine to me. So for notarization, Apple provides a command line tool called Notary Tool. So this is not included with the stock install of macOS, so you'll need to install either Xcode or the Xcode command line tools to have access to it. Again, we have limited time in the talk. I'm not going to go into the details of how to configure notarization. For those who want to know more, I would encourage you to go to the link at the bottom of the screen for information about how to get started. Now, one thing I will mention with regards to notarization is that you'll need to set up an app-specific password for the Apple ID you're using for notarization if you're using the Notary Tool command line tool. For more information on this, please see the information at the bottom of the screen. So to create to notarize a signed installer package, you would run a command like the one shown on the screen. If I was going to notarize a signed installer package named example.pkg using my personal ADC account, the command would look similar to this. Now, if you don't want to provide your app-specific password as part of the notarization command because it does show up in the clear, you can also configure your credentials to be stored in a keychain, like your login keychain, as a keychain item. So the instructions on how to do this are available in the notarization documentation that I linked to earlier. So to notarize a signed installer package using a keychain item to store your credentials, you would run a command like the one shown on the screen. Now, if I was going to notarize a signed installer package named example.pkg using my personal ADC account with my credentials stored in a keychain item named notary tool-password, the command would look similar to this. So let's take a look at how this works. So I'm going to go ahead and run Notary Tool. I'm going to tell it that I want to submit a package. I'm going to tell it that my keychain profile is Notary Tool password. And I'm going to tell it that I am going to wait. This is also why I record my demos, because normally this would take like at least a 5-minute process to happen, and this just happened in like, I think, 10 seconds. So yay for recording things and being able to edit. So along with the other functions we discussed for the package util tool, another of its capabilities is that it can tell you if packages are signed or notarized. So here's what you should see if a package is neither signed or notarized. Here's what you should see if a package is signed but not notarized. And here's what you should see if a package is signed and notarized. As you can see, there's additional information saying that, yes, it's been notarized, and it provides the signing information. Now, for those interested, I have a post on this available via the link on the screen. Suspicious Package will also be able to tell you if an installer package is signed or notarized. And for your packaging needs, there are a number of free tools available. I personally use Stephanie Sudra's Iceberg packages when I need to manually create a package, but I would say try them all out and see what works best for you. Iceberg builds legacy installer packages, which I mentioned earlier. They don't work on Sequoia anymore. I would say get away from those for now. While Packages builds flat packages. Thanks to my examples earlier in the talk that used packages, you should already have an idea of how Packages works. If you need to use source control for your packaging, I would recommend using either Monkey Package or Quick Package. Both are free and open source tools which allow packages to be built in a consistent and repeatable manner using source files and scripts. My former shop at SAP also makes a free open source tool named Script Package, which I'll be discussing in more detail in a moment. Jamf's Composer is also an available tool for creating packages, and it includes a handy feature for taking before and after snapshots, where you make the initial snapshot of the system, install your software, and then take a second snapshot once that installation is finished. Composer will then generate a list of files and directories that changed, and it'll use those changes to generate a package. Now, the main reason it is not up on the slide is that it is not free. It is available for purchase from Jamf, and is also included as part of Jamf's Jamf Pro Suite. So I would like to close out by discussing a tool called Script2Package, which is an open source app developed by my former team at SAP, and it uses package build and other Apple tools to build payload-free packages. So it is available for download via the link on the screen. And the reason I want to talk about it is that it has a number of features that can make your packaging life easier, including options to build payload-free packages that come with or without package receipts, and also choosing whether or not you want to build component packages or distribution packages. So let's take a look at how it works. So I've launched Script2Package. What I do is I select a script, hit build. In this case, I'm signing my package. Goes ahead and builds it, and it'll create that installer package at the same place that the source script is from. So what it'll do in this case, because example.sh was out on the desktop, it created example.pkg because it uses the same name unless you tell it otherwise. It'll create that same thing in the same directory, which in this case is the desktop. So another capability of Script2Package is signing and notarizing existing installer packages, as well as validating signing and notarization status of those packages. These do not need to be payload-free packages. They can be any package. Any existing package that you can sign or notarize, you should be able to sign or notarize them using Script2Package. So for those who want a simple way to sign, notarize, and also validate those packages, Script2Package is a tool that can help you. So in this case, I'm going to choose to validate an existing package. I'm going to choose my just created example package. And because when I was creating it, I had chosen both the signing and notarization options, Script2Package is showing that it was both signed and notarized. Now, this is an introduction to packaging. I'm not covering absolutely everything about it. But for those who want more information on packaging, including how to get into more advanced topics, I would strongly recommend you check out this book written by Armin, which is available only on Apple Books. So a presentation like this can really only scratch the surface with installer packages. Armin's book will help take you the rest of the way. So I've got some more useful links because you can never have too much information about this topic. Some more useful links. Some more useful links. And hopefully the most useful links you see in this presentation, because this is how you get it all. PDF with the slides and the speaker's notes is available from the top link, and bottom link has the keynote slides. So all the slides, all the demos, all the everything available from the link at the bottom of the screen. It looks like we have about a minute left, so I will open the floor for questions.
Now you scared them.